As promised, today I'm going to do some performance testing on this countertop portable reverse osmosis water filtration system. But first I would like to show you the basic water flow in this unit. When you switch diverter, your tap water will travel through the top tube into the first stage, sediment filter, which removes largest particles like sand, rust, and it should be changed about once a year. And from here water goes to carbon filter, stage 2, which removes chlorine, but I customized the system for chloramine removal also. From there, partially cleaned water goes into reverse osmosis membrane, which purifies the water by removing pretty much everything from it, the bad chemicals and the good minerals. On this side of RO membrane, there are two outlets. The bottom one is wastewater, and the top one is actually your clean drinking water, which has nothing in it, and that's the reason for this Remine filter. And from here, clean water with no chemicals and freshly put minerals like calcium, magnesium, potassium and so on goes into your drinking glass. First of all, I would like to find out how much wastewater is produced on the left side to make clean drinking water on the right side. And it looks like wastewater stream is just about twice as fast as drinking water stream, which means it would take about 2 gallons of tap water to make 1 gallon of drinking water. And that's actually pretty good compared to full-size under-sink RO systems, because they average about 10 gallons to make 1 gallon of drinking water. In this test, I would like to see how fast this 6-ounce glass will fill up. It's about 177 milliliters in metric system, and not to waste a lot of time, I increase speed of this recording. It will take 1 minute to fill up this glass, which means if you want to fill up a full gallon of water, it will take about 21 minutes. But if the water pressure in your faucet is stronger than mine, it will take less time. In order to do an accurate test of how well this system filters the water, I'm going to disconnect the tube from remineralization filter, which adds minerals to the water, and take direct reading from reverse osmosis membrane, because that's where the cleanest water comes out. I'll let the cold water run for a bit and then switch diverter to a filtration system. And I'll wait for a moment for the water to flush out. I'll fill up 1 glass to do a TDS test, which stands for Total Dissolved Solids, which basically means how much stuff is dissolved in your water. But it does not specify what it is. It could be good minerals, it could be bad chemicals, which you would typically find in your tap water. And the second glass would be for a pH test, where 7 is neutral, anything below 7 considers to be acidic and bad for you, anything above 7 is alkaline and good for you. And the third glass would be tap water to compare it to. So this is a TDS meter, and the lower the number it shows, the less impurities is in the water. Give it a little shake to remove any possible air bubbles stuck to the electrodes, and it shows 9 ppm, or 9 parts per million, which means 9 milliliters per 1 liter. And the tap water shows 234 ppm, so that's 96% filtration rate. And now let's test pH content of this water. Typically, reverse osmosis and distilled water come a little bit acidic, but that's because the water is so pure and clean it has nothing in it, and you need minerals for the water to be alkaline. Adding a few drops of this reagent turns water into yellowish color. It's definitely not green, and below 7, just about 6, as expected, slightly acidic. Now let's reconnect remineralization filter and see how much minerals it adds to the water. This Remine filter contains a wide spectrum of trace minerals that our body needs, and since we consume up to 30% of minerals from the tap water on a daily basis, it's better to purify the water first and then add minerals to it later on. And again, 1 glass for TDS test and the other one for pH test. And total dissolved solids showing 58, 57, and that means that a Remine filter put in 48 milligrams of dissolved minerals back into the clean water. And now the pH test. A few drops of reagent, and the water turns purple, which is very, very alkaline. due to those minerals in the water. And since we're testing for pH levels, let's test the tap water also. Typically the tap water in US is either neutral or slightly alkaline, and that's because alkaline water is not as corrosive to the water pipes underground. Therefore, local municipalities add additives to the water like lye, for example, to increase pH of the water. But does it make this water healthier for us because of the higher pH? Not exactly. Those additives for pipes underground, not so much for humans. And as you can see here, the water turns bluish, which makes it slightly alkaline. And in the last test, we're going to check pH and TDS of the wastewater. This water washes off RO membrane and picks up a lot of elements from it, so naturally, total dissolved solid content in this water should be the highest. Alright, let's see. Shake off any bubbles. TDS of wastewater is 337. And now let's check pH of the wastewater. It stays about bluish, so yes, slightly alkaline. And here's all the results in one page. Waste in tap water, high TDS and slightly alkaline. Reverse osmosis is very clean water with low TDS but slightly acidic. And remineralized water is very clean, full of healthy minerals and high pH for the right reasons. And if you found this video helpful, please share it with your friends, subscribe, and also hit the like button. Thanks! Promised, today I'm gonna do some performance testing on this countertop portable reverse osmosis water filtration system. But first I would like to show you the basic water flow in this unit. When you switch diverter, your tap water will travel through the top tube into the first stage sediment filter, which removes largest particles like sand, rust, and it should be changed about once a year. And from here water goes to carbon filter, stage 2, which removes chlorine, but I customized the system for chloramine removal also. From there, partially cleaned water goes into reverse osmosis membrane, which purifies the water by removing pretty much everything from it, the bad chemicals and the good minerals. On this side of RO membrane, there are two